This lesson is for section 2.3, graphing equations of lines. Now, at first here we have a little vocabulary. We're going to skip the term parent function for a minute. We'll look at that here shortly. The y-intercept for a line is where the graph crosses the y-axis. Slope-intercept form, I think we're all familiar with that. That's y equals mx plus b. And of course, the y-intercept in that case is the b. Our slope is the m, that's rise over run, and our y-intercept, that's the place where it crosses the y-axis, that's the b in the equation. The form, though, that we might not be familiar with up to this point is called standard form. Standard form is another way to write the equation of a line, only it looks different from slope-intercept form. It looks like this: ax plus by is equal to c. And in this situation, the x and the y are on the same side of the equation. Now, just by looking at that equation, you cannot determine the slope and the y-intercept. However, there are shortcuts that you can use that can help you determine the slope and the y-intercept, which makes the graph easier to graph, the equation easier to graph. So the shortcuts, I'm going to show you those right now. These are shortcuts that we're going to memorize and use in this section to help us graph lines. To find the slope of a line that's in standard form, you take the number that's in front of the x, that's the a, and you change the sign. So we go the opposite of a. And then you take the number that's in front of the y, which is the b. So you take the opposite of a and you divide it by the b. And that'll always tell you the slope of that line. So in standard form, the shortcut for finding the slope is opposite of a over b. There's also a shortcut for the y-intercept. To find the y-intercept, when you have an equation in standard form, you take the c, which is your constant, and you divide it by the b. And so that'll always tell you the y-intercept in the problem, the place where it crosses the y-axis. And there's also a shortcut to find the x-intercept. Now, we don't use that nearly as often, but sometimes we do find the x-intercept. And so the x-intercept, we use the c again, but this time we divide it by the number that's in front of the x, which is the a. So those are the shortcuts that we can use from standard form. So it'd be a good idea to try to memorize those and familiarize yourself with those to help you graph lines when you see standard form. Now we're going to talk about something called the parent function. The parent function for all linear equations is just simply y equals x. The graph of y equals x is shown down here below. For the graph of y equals x, our y-intercept is at 0. It's at the origin. And it has a slope of positive 1. So we go up 1, right 1, up 1, right 1, up 1, right 1. And that tells me, or shows me, points that the line goes through, so we can draw that line. So in general, in general, a y-intercept of a graph is the y-coordinate of a point where the graph crosses the y-axis. So the way we find the y-intercept, we identify the point where it crosses. In this case, that's the point 0, 0, and you look at the y-coordinate, and that'll tell you the y-intercept. Okay, so let's take a look here then. How exactly do we graph a line that's in slope-intercept form? Well, first, we want to write the equation in slope-intercept form if it isn't already. Sometimes they already are, sometimes they're not. Step number 2 then, we want to plot the y-intercept b, we want to identify the y-intercept b and use it to plot the point 0, b, where the line crosses the y-axis. Then we identify the slope m and use it to plot a second point on the line. Then we draw a line through those 2 points. So those 4 steps are what we do when we have a graph that's in slope-intercept, or an equation that's in slope-intercept form. So let's take a look at example number 1 here. Y equals negative 3/2 x plus 1. So first of all, the equation is already in slope-intercept form, so I'm all set there. Secondly, the y-intercept is positive 1. So we want to plot the point 0, 1, where the line crosses the y-axis. So on the y-axis then, I'm going to go up here to positive 1. I'm going to put a point. Step 3, we want to identify the slope. Now, this is a negative number, and in order to get negative 3/2, either we have negative 3 on the top and 2 on the bottom, or we have positive 3 on the top and negative 2 on the bottom. Both of those are the same as negative 3/2, so you could go either way. So we know that when we identify a slope and we use it on a graph, the top number is the rise, so a negative 3 would actually mean that we go down 3. And then the 2 is positive, that would be right 2. That would put us at this point right here. On the other hand, if I used positive 3 over negative 2, the positive 3 on top for the rise would tell me to go up 3. And then a negative 2 on the bottom would tell me to go left 2. So that would put me at this point. So either way, you can see those line up in a straight line. So now I can go ahead and draw my line through those points. So once we plot that second point, starting at the point 0, 1, which was our y-intercept, we moved down 3 units and then right 2 units. So the second point was the point 2, negative 2. Then we drew our line through those points. Again, you could have went with positive 3 over negative 2 instead. And actually, it's really a good idea to do both. Even though 2 points identify a line, 3 points is even better. And you could even go more than that if you'd like. Now, if we're using standard form, though, in this case, we want when we have an equation in standard form, it might be easiest to graph if we can identify the x and the y-intercepts in the problem. To identify an x-intercept, we can let y equals 0 in the problem and solve the equation for x. Then we can use the x-intercept to plot a point where the line crosses the x-axis. Next, we can identify the y-intercept by letting x equal 0 and solving for y. We can use the y-intercept to plot the point where the line crosses the y-axis. And if I know the x-intercept and the y-intercept, we can draw a line through those 2 points. Now, having said that, we could also use the shortcuts. Remember, to find the y-intercept, well, that's c over b. And to find the x-intercept, well, that's c over a. And so those would be shortcuts to finding the x and the y-intercepts when we do this. And so let's look at an example here and see how this might work. So we're going to take a look at example number 2. 2x plus 3y equals 12. Now there's a couple different ways we could do this. To find the x and the y-intercepts, well, first of all, to find the x-intercept, we could put in 0 for the y. Since 3 times 0 is 0, you just get 2x equals 12, which means x has to be 6. So if we let y equal 0, x is 6, that's the point 6, 0. So on my graph over here, 1, 2, 3, 4, 5, 6, 0 is right here. Then we can find the y-intercept by putting 0 in for the x. Now 2 times 0 is 0, so I just get 3y equals 12, which means y has to be 4. So if x is 0, y is 4. So that's the point 0, 4. So I come over here to my graph, 1, 2, 3, 4. There's the y-intercept. And now I can draw my line through those 2 points. Now, like we said, though, we could use the shortcuts. This equation's in standard form. It looks like ax plus by equals c. To find the y-intercept, we just do c over b. In this problem, that would be 12 divided by 3, which is 4. And again, on the y-axis, I go up here to 4 and put a point. To find the x-intercept, well, that's c over a. And so in this problem, that would be 12 over 2, which is 6. So again, on the x-axis, I go over here to 6 and put a point and draw my line. We could also, in this problem, use our slope to help us with this situation. Of course, our slope, the shortcut is opposite of a over b. In this problem, that would mean negative 2 over 3. So if I start at this point, I would go down 2 and right 3. And then if I go down 2 and right 3 again, sure enough, I'm back on that line. So that even provides another point that I could use to help me graph that line. So again, there's a couple ways you can find the intercepts. If you let the opposite variable be 0, you can find an intercept. If you let x equal 0, you find the y-intercept. If you let y equal 0, you find the x-intercept. And you can also use the shortcuts for the slope. The next thing we're going to talk about is horizontal and vertical lines. Now, a horizontal line is one that has a slope of 0. And our equation in general, if it's a horizontal line, it only has a y in it. It's going to look like the line y equals c, where c is a number. Again, it's a horizontal line, and it goes through the point 0, c. A vertical line, on the other hand, the one that goes straight up and down, well, that's going to look like x equals a constant. And so that would be the point c, 0. And that'll tell us a point that line goes through. It gives us the x-intercept. So let's look at example 3 here. We want to graph y equals negative 1 and x equals 2. Now again, if it has only a y in it, it's always a horizontal line. So for y equals negative 1, it is the horizontal line that passes through the point 0, negative 1. So I go to the point 0, negative 1, and I'm going to draw a horizontal line through that point. If it has only a y in the equation, it's a horizontal line. Notice that every point on that line has a y-coordinate of negative 1. On the other hand, for x equals 2, well, in that situation, it's a vertical line. In fact, anytime the equation has only an x, you're going to have a vertical line. And it's going to go through the point 2, 0. And so if I go to the point 2, 0, which is right there, this is going to be a vertical line. So that one is the line x equals 2. And so notice that every point on that line has an x-coordinate of 2. So again, to quickly review here, when we're graphing a line, we might have slope-intercept form, y equals mx plus b. In that situation, the m is the slope, and the b is the y-intercept. We also can have standard form, ax plus by equals c. In that case, to find my slope, I do the opposite of a over b. To find the y-intercept, we do c over b. And to find the x-intercept, we can do c over a. Those are shortcuts that we can use to help us identify points and graph the line. And finally, a horizontal line, always has y equals some constant. A vertical line always has x equals some constant. And so if there's only a y, it's horizontal. If there's only an x, it's vertical. And if you can remember those things, graphing a line should be easy.